Today, we are diving into a totally new kind of AI coming out of Meta. And get this, it has nothing to do with language. It's a technology that could seriously shake up the future of AI and pose a real challenge to the text-based models that we've all gotten so used to.
You know, when you think about AI, what pops into your head? For most of us, it's probably this, a blinking cursor on a screen just waiting for us to type something. Models like ChatGPT have completely shaped our idea of what AI is through language. They talk, they write, they think in words. But what if that's not the only way? What if it's not even the best way to build true intelligence? And that's the massive question people are starting to ask, especially after Meta's AI chief, Yann LeCun, dropped a paper on this completely different kind of model. It really makes you stop and think. Is this whole large language model revolution we're living through just one possible path? And maybe, just maybe, not the most important one in the long run? Okay, so here's how we're going to break this all down. First, we'll look at the big problems with language-only AI. Then we'll dive into the new philosophy behind this model. We'll explore the difference between understanding something versus just describing it. We'll check the performance stats to see if it's actually any good. And finally, we'll talk about what this means for a future that might not be so wordy. So to really get why this new model from Meta is so radical, you first have to understand the fundamental weakness of the AI that we're all using right now. And it all boils down to this one simple idea: the problem of talking to think. You see, almost all the AI we interact with is generative. When you ask ChatGPT a question, it literally makes up the answer one word at a time. It generates the first word, then it thinks, okay, what's the most likely second word, then the third, and so on. It has no idea what the final answer is until it's actually finished saying it. It's figuring things out as it goes, token by painful token. And this slide just nails the difference. On the left, you've got your standard LLM. It talks to think, kind of like a person who's just rambling to figure out their own thoughts. But the model we're talking about today, VL-JEPA, is the exact opposite. It knows, then talks. The understanding happens first, internally. The words, well, they're just an optional feature, a way to explain the understanding if you ask for it. It's a completely different way for an AI to reason about the world. Now, this isn't just some small technical update. This is a completely different philosophy about what intelligence even is, and it's being driven by one of the godfathers of modern AI, Meta's very own Yann LeCun. And this quote right here, this is everything. LeCun is basically arguing that we've got it all wrong. True intelligence isn't about being good with words. It's about building an internal model of how the world works and being able to predict what's going to happen next. Language, that's just how we communicate that understanding. It's the byproduct, not the intelligence itself. And so here it is, the model built on that very philosophy, VL-JEPA. It's a non-generative model, and its whole job is to watch videos and build that internal understanding. It's not trying to predict the next word, it's trying to predict the next concept. It works in a space of meaning, not a space of words. Okay, so that's the theory, but how does this thing actually work? Let's take a look at how VL-JEPA literally sees the world and why it's so much more than just slapping labels on video frames. So a basic vision model is purely reactive. It looks at frame 1, guesses a label. Looks at frame 2, guesses another. The result is jumpy, it's inconsistent, and it has no real memory of what just happened. VL-JEPA, on the other hand, thinks in terms of time. It watches an entire event unfold and builds one stable, coherent understanding of what's happening from beginning to end. You can almost picture its thought process like this. First, it just takes in the video feed. Second, as it watches, it starts forming a cloud of possibilities. Think of those as little red dots, all its instant guesses. But as it gets more information over time, those guesses start to collapse and converge into one stable, confident understanding, that solid blue dot. And only then, third, does it confidently label the entire event. And this is the perfect analogy. The cheap model, it's like a dumb motion detector on a security camera, just screaming, motion, 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 every time a shadow moves. VL-JEPA is the security guard who actually watches the footage and says, oh, I see, that person is picking up a package. It understands the intent and the entire action. Okay, so the philosophy sounds good, and the idea is really cool. But does it actually perform any better? Well, let's take a look at the scoreboard. This chart shows how well these models did on zero-shot classification. That's basically testing how well a model can identify actions it has never been specifically trained on. And the results are pretty darn clear. VL-JEPA comes out on top, beating out some other really well-known models. Why? Because its fundamental understanding of the world gives it a massive head start. But this is where it gets really mind-blowing. VJPA doesn't just perform better, it does it while being way less complicated. This chart compares the number of trainable parameters, which you can basically think of as the size and complexity of the model. I mean, just look at that difference. The traditional models are huge and bloated. VJPA is incredibly lean. So here's the bottom line. VJPA gets better results using roughly half the parts. In an industry where computing power and energy are massive bottlenecks, doing more with less isn't just a small improvement, it's a total game changer. All right, let's connect all this back to the bigger picture. Why does having a more efficient AI that actually understands the world, why does that matter in our day-to-day lives? LeCun himself puts it perfectly. We have these language models that can do incredible things, like pass the bar exam or a medical licensing exam. But we still don't have a robot that can reliably clear the dinner table. We don't have truly self-driving cars, because those things require a deep, intuitive grasp of the physical world. And that's something you just can't learn from reading text on the internet. And this is exactly where VJPA's approach is so critical. For things like robotics, for autonomous agents, for any AI that needs to actually do stuff in the real world, you need a model that gets physics, that understands that when you let go of something, it falls. You need a model that understands, not one that just describes. At the end of the day, it's all about thinking efficiently. To predict what happens when a glass falls off a table, an AI doesn't need to simulate every single atom in the glass. It just needs to get the basic concepts of gravity and fragility. It's about learning the world at the right level of detail. And that's exactly what this JEPA architecture is designed to do. Which brings us right back to our big question, but with a new twist. For years, we've been trying to build an AI that we can talk to, but maybe, just maybe, the next great leap forward will come from an AI that doesn't have to say a single word, one that just watches, understands, and then does. So is the most advanced AI of the future a silent one?